like chunking is dead? And then, like, do you concur? I concur. Yeah.
No.
Hi everybody, welcome to another YAAP episode. And today we're going to talk about chunking. And Nave, let me ask you this. Is chunking dead?
I don't think so. It's actually a very important thing of any RAG system. It's an important part because it lets you store things in an efficient and informative way, so you can access them quickly and accurately when you retrieve data. But probably chunking is not best used so far.
I think it's the least talked subject in RAG or AA agents in general.
Yeah, I agree. I think that many benchmarks assume chunking up front, and people are trying to optimize other components in the system, such as the agents that operate in an agentic RAG system, or the retriever itself, the embedding model. But sometimes the chunking is the terminal to the success of retrieval.
Okay. So maybe give me like 1-2 sentences on every chunking method that is popular today.
I think that the most popular one is the most naive one, maybe. You can see that this is what OpenAI uses by default, or Google. This is just plain sliding window chunking, sometimes with overlap. And you try to choose a single window size that you go with, like 500 tokens, 600 tokens, 400 tokens. Anyone can choose their best one that fits the data best. But this is the most popular one. And there are other methods to enhance that, because when you split the data in such a data agnostic way, you find yourself splitting things that shouldn't be split, or are not so well suited to questions that will come later.
Yeah, it doesn't, like, it just split it in a very hard threshold.
Yeah,
right?
so people are trying to add some heuristics, like split it at the end of sentences, or so you don't split it mid-sentence, or at the end of sections, or when you have a new line, or any other heuristic. But it's not enough, so usually there are other methods to enhance that, such as Raptor, that tries to combine chunks in a hierarchical way. Or you have contextual retrieval by Anthropic, that enhances the data that chunks with information about the whole document to try to overcome the contextualization loss that you get when you split the data.
Okay, and essentially what I want to talk to you today is about the project, a very, very cool project that you did here, about multi-window chunk size, right? So can you maybe give us the overview?
Yeah. So we, maybe just a bit of background before. We started by trying to find the best chunking method or chunk size for our benchmarks, for our clients. And we came up with 500 tokens and, 100 tokens overlap. And we try to enhance that with markdown properties and other things. But we found ourselves optimizing that and getting to clients, and it's not working. And we actually saw that some chunks are not retrieved because the chunking method that we chose is not well suited to the questions themselves. The questions address larger segments or smaller details that are not captured. So we asked ourselves, is it possible that we need several chunk sizes? Maybe there is no single chunk size that fits all questions. And we decided to index the data multiple times. So we indexed it with several chunk sizes, and we started by asking ourselves, is our hypothesis true? And does it really hold in the real world? And we saw that consistently across benchmarks, if we had a method to choose the best chunk size per question, we would get a vast improvement in performance.
But we do have to address the fact that there are several copies of the dataset.
Yeah.
Right?
Yeah, there are several copies. It's like a classical time memory trade-off. Instead of investing more time during the retrieval phase and going through all the documents or a large set of documents in the retrieval phase, you choose to invest the time and the money in the offline phase where it matters less to us, at least. So we have several. So we now have several indices per a single data set or a single corpus, and during the retrieval phase, we retrieve from each one of these indices. We retrieve top k chunks as usual.
So let's say we have 5 windows.
Mm-hmm.
So we're doing the retrieval part 5 times.
Yeah.
And then we have 5k ranks. That's
Yeah.
5 ranks of k documents each.
Exactly. 5 ranks of k chunks each. We say that each chunk is like a voter for its parent document. And then we use the classical ranking fusion method called RRF, or reciprocal rank fusion. And we fuse all of these together. And we find it to be a nice proxy for the Oracle experiment I told you before, that we chose the right chunk size per question. And we managed to get really nice improvements across many data sets, including MTEB, which is or BEAR, which is a very popular retrieval benchmark, Finance Bench, QMSum, Narrative QA, many benchmarks saw the uplift, and it was very nice to see that different questions really benefit from different chunking strategies. So instead of binding yourself to a specific one, I think that multiple chunk sizes can give you the benefit that you are looking for, instead of the many heuristics that we talked about before, or other methods that try to train specific models to overcome the issues of chunking. The fact that small chunks lose context, large chunks lose details. You can have both.
Let me play a little bit the devil's advocate here, because you know I like to be on the red team mostly. But is it actually relevant in this day and age of AI agents, where agents simply do everything by themselves, so it seems?
Yeah.
Do chunking still have meaning?
It's a good question. I think so, because as you can see in many recent works, including DeepSeek search or many other deep search agents, you can see that the retriever is usually fixed. And people are trying to optimize around the retriever instead of the... and then they have like a ceiling of where they can go. Because if a data is indexed in a way which is just not possible to find, because the clues in the questions or the cues that you get in the questions just don't appear in the data itself, because you split it in a way that loses it, or your embedding model just cannot capture so many details because you try to make your chunk size so large, so the context will be intact, and you lose the fine details that you're trying to look for, and then you are in a place that no matter how many rephrases or different approaches you try, you just may not get to the right document. And we actually saw it.
Okay, cool. I'm sold. Chunking is live and kicking, I guess. So what's next after this? Right, we published a blog post, did some experiments. Where are we taking it from here?
I think we, by itself, it's already a nice solution, but I think we can do better in the fusion. The fusion is quite naive with RRF. It doesn't take into account several factors like the length of the documents. And we for sure can do better. We can use like better models or methods to combine different ranks. We can optimize the costs of indexing. We can take a look at the trade-offs between the embedding model size or dimension and the number of windows that we use to minimize cost. So we have a lot to go here.
Okay, cool. Thank you so much for the explanation. For the rest of you, check out the blog post, check out the notebook, and thank you.
Thank you.